there will be no real non-controlled currency in the world.
We're coming for you, banks.
Increasing the block size to 32 megabytes right now. What would be the top 5 arguments that would get hurled against me?
Oh, that's a good one.
There are a few that the big blockers got right.
Ching, like all these coins splash into the wallets of all the winners. I love that.
There's a new threat out there. It's crypto.
Hello and welcome back to the Bitcoin Cash podcast, following Bitcoin Cash on its rise to global reserve currency. This is episode number 122, VM limits, featuring Jason Dreyzehner. Today is Friday, the 26th of July, 2024. And if you haven't heard a Jason Dreyzehner episode before, we did one on episode 79. We have a special reminder, which is that if you're feeling confused or you're not following what's going on, relax. That's a good thing. That's what it feels like when you're learning. So just stick with it and maybe listen to it a second time. All right. We got to start quickly just with the price. I don't want to spend too much time on this because we've got a lot to cover. USD $376.62 per 100 megasats, which is flat. 1 BTC 179.2 BCH. So we're way down. BTC having a good week with the conference. 1 ETH 863 megasats, also flat. Any quick thoughts on the market, Jason? No. All right. Fuck it. Yeah. Never mind. Let's move on. Okay. Our guest today is Jason Dreyzehner, who is the author of LibAuth, Chain Graph, and BitAuth, as well as the CashTokens chip author and the VM limits chip author, and probably does other stuff too. Is there anything I'm missing on that list that is in your resume currently for BCH?
That's the big stuff.
Everything. Okay, yeah, that's the big stuff.
BitAuth being the BitAuth IDE, the development environment for contract development.
Yes. Okay, that's what I meant. Yeah, BitAuth IDE. Yes, I forgot to type that in. Otherwise, generally,
that's historical.
Yes. Okay. All right. We haven't caught up with you in a while. So just briefly, give me your thoughts on how's BCH doing overall at the moment. Did you watch Bliss? Are you liking where the community's at? How are you feeling about the revolution?
Yeah, I think it's going great. We're what I'm probably most positioned to comment on is where we are technically. And we're in a very good technical spot. A lot of past upgrades have been about enabling applications on Bitcoin Cash, and even this limits upgrade proposal is more about improving the efficiency and kind of the simplicity of deploying big applications and reviewing them carefully. It is actually possible to build. Basically, anything you want to build is possible to build on Bitcoin Cash right now. It just requires quite a bit more complexity because we have to break contracts into a number of outputs. So limits is a meaningful solution there. And then there are some other upgrades on the horizon that I'm very excited about that will also take that development and review burden down another couple orders of magnitude probably. That's the BigInts and possibly loops in the next year or two. So I'm very excited about where we are. Development wise, we're in a fantastic spot. There are actually very few cryptocurrencies out there that are really even close on having both on-chain representable assets that work like CashTokens and having a contract system. The field is very thin. So yeah, I'm very excited.
Yes. Okay, interesting. How much do you pay attention to those other ecosystems? ETH, BTC, I don't know, Solana, that's the hype thing at the moment. Mm-hmm. Do you pay much attention to all that?
Enough to know what the technical boundaries of each are. We're doing really, really well.
Okay. All right. That's a pretty good summary. And you also gave me unwittingly an amazing compliment recently. You sent me a Telegram message saying sometimes you need to get the news. So you just go on my Twitter page and look like what's the banter, like, that's more relevant than anything else, in terms of keeping an idea of what's going on in the scene. So tell me, I posted about a ton of shit and very little of it is technical. So what do you make of everything where we're at the moment, on that front?
Yeah, I definitely appreciate going, I probably like once a week or something like that. I'll just roll through your Twitter X profile or whatever and look at whatever you've typed and a few others. The algorithm is not very generous and not wasting my time there. So I try not to touch it. But I appreciate that you and a few other accounts do well at isolating the things that I care to look at, both from the Bitcoin Cash world and then also, things that I definitely am not paying attention to, like the drama and, whatever land.
Yeah. Well, we're trying to have too much drama. Somebody said to me like a little while ago something about like, oh, this is the Bitcoin Cash podcast. Like, why are you talking about X, Y, or Z? And I was kind of like, well, because it's all interrelated. If it's politics or it's anthropology or it's psychology or like whatever is coming in, I think we keep this show pretty focused, but a lot of stuff is relevant in the world, especially in the economic markets, so we have to touch on that here and there, but glad we can be your little lifeline to the rest of the world.
Yes,
okay.
Well.
All right, let's crack on. Let's get to the meat of it then. So VM limits, my summary, as I understand it, right, is that the chip process, which landed ABLA. Actually, let's just quickly get your thoughts on that. What did you make of the ABLA rollout and so forth?
It was great. That was something that we've all known has needed to be done for years and years, like since 2013, I guess, 2014. So it is nice to see. It's taken about a decade actually before some of the earlier proposals for it to finally land. And it just took a lot of thinking and full research, I would say. So it's nice to have that essentially just happen. I was not involved at all until I posted my big giant approval statement sort of in October or November, whatever it was. So I was very excited to see that essentially just happen. And it's great that that's done now.
Yeah, it rolled out smoothly. We had the brief moment where the 32 megs like ticked up a little bit, right? So that we knew that it worked, which was nice to see. But that's just been, that's now completely off the sort of agenda, really, as far as the BCH community is concerned. Although one thing I've found really interesting is that Callisti was talking about, he went to the BTC conference, he's there now, right? And he said, he already talked to a couple of people that knew about ABLA, right? So this has been by far the most successfully marketed upgrade I think BCH has ever done. And we've got to try and figure out, I'm currently trying to like cook up something in my mind. How can we get everybody talking about, VM limits or something else? Because like CashTokens was okay, and all the ones before that, literally nobody has heard of unless you're deep in BCH. But I think that makes a big impact if people hear about our upgrades, so I'm not quite sure how we can't be theming it all around Jessica ABLA every year, but that seems pretty popular. So I don't know if you have any thoughts on how we should market VM limits or get the word out.
I'm afraid not. Not that on the marketing side.
Right.
The proof will be in the applications that get built with this stuff. And a lot of this was, we're sort of, in a way, we're sort of catching up after, 15 years of not touching this stuff, not fixing any of this stuff. So it's taken a few years, since I started looking at it, but, even in the, right after Bitcoin Cash forked, when many of the opcodes were reactivated, the amount of development work it took to get from essentially where Satoshi left in November, December of 2010, with things in quite a state of disrepair for the contract system. And it's taken a while for us to get back into a forward moving position. But yeah, I think, it will become very clear that our contract system is really great in a few years of just the tooling improving, and we just need a few developers really building proper protocols with this stuff, and you'll start to see the scaling property differences. They're kind of night and day, tens of thousands of times.
Yeah, brilliant. So from what I understand, VM limits is this idea that, well, you can walk me through it, but back in the day, just go for it.
So in general, the VM limits chip, it's a Bitcoin Cash improvement proposal. That's the chip acronym. Is a proposal to retarget how the virtual machine that is built into Bitcoin Cash limits what you can do with contracts. So first, probably a good place to start is, if people are not familiar, Bitcoin Cash has a contract language. It was developed with a contract language by Satoshi in 2008 and then released in full in 2009. It has had that since day one. In the earliest days, it essentially had no meaningful limits. It had arbitrary precision arithmetic. It had essentially no limits on how long your contract could be. The only meaningful limit was that your transaction had to be within 1 megabyte, basically.
Was there a block size limit at that time, or it was just 1 megabyte transactions?
I believe it was just a transaction limit, because the block size limit first was, if I looked at this very recently, was first soft forked in, I think, July 17th, 2010, and then later enforced after a scheduled hard fork, if you will, I guess a scheduled soft fork at like block 74,000 or something like that. And that was in like August, I think. I have some notes I can send them on, but so the script system that Satoshi originally put together. Sorry, I got to digress a little. The purpose of the script system is to be able to write new types of transaction schemes, like escrow things and multi-signature. Like if you have a bank account that requires 2 people to sign, there's a number of things that end users want to be able to do with their money. And Satoshi's design goal at the outset was to build a system that was complete enough that users could continue upgrading how they used transactions without having to change the protocol constantly. And so it was a relatively new idea at the time. These days, it's described as crypto agility, and in our case, it's more than just crypto. It's also all sorts of other transaction protocol strategies. But in general, it allows us to do all sorts of multi-sig, escrow, time delay fallbacks. You know how, like at a bank, one way that banks keep their vaults safe is they have vaults that only open 30 minutes after you try to open it. And there are all sorts of different protocols like that are important, both for keeping money safe, but then also for building kind of larger decentralized protocols, like an on-chain order book that lets you swap cash tokens for Bitcoin Cash or whatever, decentralized exchanges and prediction markets. There's lots of things you can do if you have an expressive contract language to work with. The VM limits chip is very specifically kind of surgically modifying some of the limits that Satoshi essentially emergency patched in July and August of 2010. Just taking another look at those limits and figuring out how to make the operations that are not very expensive allow contract authors to use as many of those as they want without changing the overall cost in the worst case of evaluating any contracts.
So when you say the cost, what does that mean for people who
in terms
don't know
of
what cost means?
just how long it takes your computer to verify the transaction. So we're talking
CPU cycles, RAM,
and
memory.
Exactly.
Okay,
compute and memory requirements. So the general goal of the VM limits chip is to not touch compute or memory requirements at all. And that's important to maintain the overall scalability of the system. Right now, the contract system requires so little validation power that it essentially it barely factors into the scaling question for a lot of Bitcoin Cash nodes. Most nodes are bottlenecked on other things, not on the script system, and we want to make sure that remains the case. So the goal with the VM limits is to retarget those limits in a smarter way, so that they are less exploitable by bad actors, and so that honest contract authors get as much power out of them as they currently as malicious actors currently can get out of them. The current limits are targeted fairly naively, and so a malicious actor can make the network spend 10 times longer validating their transaction than an honest contract author typically would use. And with those limits, honest contract authors are meaningfully limited in what they can actually make. So it is possible now with cash tokens to break apart your contract into lots of inputs. And so it's technically possible to build anything, but it gets very difficult difficult and inefficient to do it in some cases. So retargeting those limits to be a little bit smarter and be less exploitable is just a useful step forward to making contracts more useful.
Okay. All right. So why did Satoshi have to put these limits on in the first place? I mean, you're talking about like malicious actors there. And like you said, you want to keep the worst case the same. So the worst case doesn't get worse, but the best case doesn't get better. How do we know that that worst case is correctly targeted? Shouldn't we look at either, improving on that? Like I'm thinking, you have a ceiling and a floor. Instead of just raising the ceiling, if you could also improve the worst case, right?
Yeah, and in that analogy, you have if you have a ceiling and a floor, and there are a few places where there's essentially just a vertical pole that goes all the way to the ceiling, and almost all of the other operations take up almost nothing. So we're charging the same in terms of operational cost. We're charging the same for swapping items on the stack as we are for the largest possible hashing operation. And those are like several orders of magnitude difference in how much they cost the network in general. So yeah, I can back up to kind of the history. I would say it is useful to understand sort of the whole history of how we got to where we are in script, to have a sense for exactly why things are where they landed. When Satoshi first released Bitcoin script, and there was the script system that was built in, it was clearly he was working on in 2008. He sent pieces of the code to some people before 2009 via email. We have some of that still around, and then published it publicly in January of 2009, and that's when the blockchain started. The version of the script system that was released then essentially did not change until about a year and a half later, in mid 2010. Seemingly prompted by essentially a Bitcoin Talk forum post where Gavin Anderson, the kind of the second lead developer of Bitcoin, asks, "What's this script thing? What is this?" He's like,
it took a year and a half before anybody realized that this was like in there.
Yeah, in general, like no one had experimented with it at all on the main chain. Presumably some people had looked at it, but they hadn't made any noise about it. And Satoshi had not yet explained it as far as I can tell, in any public context. And June 17th, 2010, Gavin posts on the forum. He's like, "What's this script thing? I mean, it looks cool, but doesn't it seem kind of exploitable? Like, it's kind of funny that I can create a contract that creates an address that anybody can pull the money out of." And he's like, "Yeah, if you just put opt true or whatever, then anything spends that address. It's an anyone can spend address." And I think that's actually where the
that's what happened with Taproots, right? That? That's literally what happened with Taproot and the inscriptions exploit on BTC.
Those upgrades were deployed on BTC land. but so basically June 17th, that happens on there's some discussion on the Bitcoin Talk forum, and there's this curious period where it takes Satoshi like 8 hours or something to respond, and he responds a little faster in some cases like this, and so it makes me think that like he probably saw this pretty quickly and was going to look at it because he'd not looked at it in a little while. You can tell that like he's patching vulnerabilities at this time. Mid-June 2010, he's already started like working on hardening the client a lot for the past like 3 or 4 months, and of course since 2009 he's been working on it. But there's this clear push where he's going through and pulling constants into consensus code and clearly thinking very hard about how peers work and who talks to who and who sends address information to who and at what frequency. And he's bumping things and moving things. And then Gavin's like, hey, what's this script system thing? And there's this little pause. And then he responds later, like explaining, his kind of thesis for why it's good for Bitcoin to have a contract system that is so configurable. Like you can create a new kind of address to do a lot of different things. And people are like, oh, that's pretty cool. And there's a few more posts and they're like, this is actually the same thread where there's some discussion about creating another consistent implementation that is a second implementation. And this is actually the context where Satoshi is like, no, I think the quote is menace to the network. He's like, you shouldn't do that because, and there are more words, but in essence, shortly thereafter, he's like, because it's already difficult enough for me to fix all the bugs. And if you have another implementation, I won't be able to sneak these fixes in. And he's sneaking fixes in constantly. It's fun to know the context of when he said, a menace to the network, another node implementation would be, and he doubles down on it a little bit more a couple posts later. I think when he's gone and looked at the script system, he's like, oh man, we're going to need a lot of changes. Because about a month later, he rolls out by far the biggest change he made probably to anything, but certainly to the script system. Adds the 1,000 item stack limit, adds a limit to the number of bytes that can be processed. Before, there's essentially no limit, and it was just an implicit limit based on the size of the peer-to-peer messages, and by the transaction size. Notably, he removes in operation op version, op ver. So this gives us a sense for how his ideas about consensus on the network are evolving, because it took 1.5 years for him to remove that. And what op version did is it pushed the version of the Bitcoin node software you're running. It pushed that to the stack. So op version is like the most perfect self-destruct button that could ever be developed for the Bitcoin network. So it was quite literally possible to create just a set of transactions that would perfectly split every single implementation of Bitcoin that was ever shipped. So normally we worry about a consensus vulnerability where someone will send a transaction and there will be 2 different sides of the network. Well, in this case, you could have sent a set of transactions, and every single implementation that has ever been released would have its own chain, all at the same. The fact that until now he has this active gives us a sense for kind of where his thinking what had developed on how consensus works at all. And it's notable that he thought that the version opcode would be a way to upgrade the network. So he hadn't quite wrapped his head around what it looked like to actually ship a contract language in the consensus code of a system like this and then be stuck with it basically. And so I think at the same time, he also ships all the op-nop 1 through 10 codes. And there's a few other things. He also limits numbers to 258 bytes. And that's bytes, not bits. So 2064 bits. So still like massive numbers, bigger than is used by practically all of classical cryptography, except for the highest key sizes of RSA. there's some more modern stuff that starts to use higher levels, and post-quantum crypto now uses higher numbers as well. But for most classical cryptography, that's well in excess. But it's notable he had no limits before, and then adds those limits now. And then like 3 days later, he ships and I should also note, all of this is being snuck in. So all of that was shipped in a commit, or at the time it was a subversion check-in called like revert whatever.xml. Yeah. And it's clear that, like, I don't know, it seems like he merged a terrible patch and then reverted it right away so that he could sneak the stuff into the revert. And then 3 days later, he does some more stuff. He adds like I think I even have it on let me look at the, I
love this. This is great stuff. This is because I'm always on this show trying to help people get a more accurate idea of how they should think about Satoshi. And one thing I've said before is that Satoshi was an engineer. People love to think of, this economic genius or this philosopher or this freedom fighter or something like that. And yes, that's all true. But Satoshi was primarily, first and foremost, an engineer who shipped a working system pretty much solo, in this incredible, like, once-off in human history type of launch. And obviously in the early days, just kind of, it was Satoshi's project and just did whatever they wanted, even with with the community, starting to use it a bit, right?
Yeah. And it's clear that now, and I actually emailed Gavin. I've not heard back from him. I just emailed him like 3 days ago, though. So I haven't talked to him since 2022 or so. But I was asking if he had any notes on. I recall he's said in public a few times that he went back and forth with Satoshi about the script system at this time, and so I'm curious what that discussion looked like, because it would be good to know exactly what Satoshi knew also at the time. I just looked over real quick at my notes. Then 3 days later, he adds the opcode limit, which we still have. He limited it to. It looks like he attempted to limit it to 200, but then later fixed that consensus code and made it clear that it actually limited it to 201 because of the order of operations in that line. So and further limits the stack size. What is it? Let me see if. Yeah,
10,000.
No, okay, but yeah, he actually left the push length limit still at 5,000 bytes. But and notably, he left the arbitrary precision, near arbitrary precision arithmetic in. It was another few weeks before it finally it clearly gets a better sense for just how tricky this whole consensus code thing is. And back in February of 2010, he had already found a bug in OpenSSL's implementation of right shift that caused it to crash on Ubuntu 9, but work on Ubuntu 10. And clearly in this couple weeks, he is coming to terms with that causes a consensus split. So about 2 weeks later, you can see he just kind of gives up on doing this right now and disables a bunch of opcodes in a super sneaky way. Does it in a place where unless you're actually paying attention, you might just think that it was kind of trivial logic, because he leaves the logic in for all of the opcodes. He just has them fail in a different place.
And a quick note to listeners, now that famously includes opcat, which over the last 2 years we've seen Eric Wall and the Taproot Wizards try and sneak in large on the BTC side, largely through this. Satoshi had it. It was always in there. The logic is still there, and they're trying to use that to build credibility for it, which is basically just a historical accident that Satoshi didn't have time to properly, disable it or dig it out, right? So anyway, that's just an interesting modern point of trivia.
Yeah. So he's disabling all these opcodes, and then critically at this time, he's also trying to remove dependencies from consensus critical code paths. And one of those dependencies that he is already, he already doesn't trust at all is OpenSSL's big number implementation, because he already stumbled on a crash in February. So he's, accidentally made it crash in February. And he's like, there's no way we can make this part of the consensus. And so he clearly rips it out fully, and he limits big numbers to 4 bytes in the script system. And notably, people sometimes wonder why script numbers, why the VM numbers in the virtual machine for Bitcoin and for Bitcoin Cash, people wonder why they're so strange. They use a signed magnitude format, which is the format that the OpenSSL big number implementation used. And it's actually a design decision, of course, of that implementation, because signed magnitude is a little bit more efficient for arbitrary precision arithmetic, or at least a little bit less complex to implement. And so a lot of our arbitrary precision arithmetic libraries lay out numbers the way that the Bitcoin virtual machine does, which is a useful thing to note. And maybe we'll talk about it later, but that's among the reasons why I finally, after years of thinking the opposite, thinking that we would essentially stick with 64-bit math, and that the contract authors would use essentially emulated precision, because we can't know exactly how high the precision they would want to use is. I fought with that possible direction for quite some time, and kind of finally demonstrated, at least for myself, that it would be quite silly for us not to extend the limits also on virtual machine numbers for Bitcoin Cash. So that right now they're limited at 4. In 2022, we bumped it from 4 to 8. Bumping it beyond that would have been risky, because we needed to deal with these other limits we still needed to untangle a lot of the issues that we are still around from July and August of 2010. That hopefully gives a sense. And we'll talk maybe a little bit later also about the loops proposal, which I now plan to propose for 2026. And I think that it's, when talking about this stuff, it's really useful to have, a sense of, the Chesterton's fence thing. It's important, why a fence is there before you propose to remove it. I'm much more confident now, just in my VM limits work this past 4 months or so. I've benchmarked a lot and reviewed a lot of nooks and crannies of how this, not just on like the C++ implementation, but in like a naive implementation written from scratch in another high level language. I'm trying in a JavaScript implementation.
You wrote a whole JavaScript node just to test this out?
I had already written it, so it's not new. It's LibAuth has had support for this stuff since 2018. The JavaScript implementation in LibAuth is a great one to test on, because it's so weird. It's very strange. It's almost written as if it was written in Haskell, but with in Haskell flavored JavaScript. It's a functional programming approach to everything. Like the overhead of each operation is like way higher than it is in the C++ implementation, and so there's some pretty important relative differences between the JavaScript implementation and the C++ implementation, and so it gives us a good cross section of like that. For example, the JavaScript implementation also has a lot of very naive data structures, and the C++ implementation is way smarter about how it handles a lot of stuff. It also is pretty naive on some levels, but it's a useful, between the two of them, it's a very useful cross section of what are the possible implementations of this higher level protocol. And so I built quite a bit of confidence in it over the past 4 months or so. And I was just right before I got on, I pushed up as much as I could. I still have more to release, but I've been trying to get this out for like a week or so, and I just pushed whatever I had and shipped it this literally an hour ago, so that people can be looking at it in the chat and such. But it's useful to have also a sense for like an historical sense for what Satoshi was thinking at the time, to get a sense for why the script system doesn't have loops already. The very first implementation of the script system is clearly I would call it like an academic approach to the topic, where it is technically solved. He's created a script system that will work forever, and because it has no meaningful limits on anything that's important. And so, you'll never have to hard fork or whatever. And every contract is technically tractable, technically computable, because it's technically not Turing complete. But in practice, it's possible to make it fall over in 100 opcodes, right? Now you just op, dupe, op, cat, and so duplicate, concatenate, and you can do that and spend 30 gigs of memory, and then it crashes, right? So clearly, he had thought a lot about what the kind of the developer experience is of this. And I think he picked a really good base language. The fourth language was a brilliant choice. And people think it's weird and esoteric. And so they don't really look at it too hard. But honestly, efficiency wise, it's a very expressive and concise, and it's easy to have very consistent implementations. It was a shockingly good choice, and I think that's
everything Satoshi did. He only made one mistake. The 1 megabyte limit, that was Satoshi's one mistake. Yeah. All the other stuff he nailed, all the cryptography, the economic design is unreal.
Yeah, and so the script stuff, it's clear he was approaching it more from an academic perspective. He kind of got in my opinion, got the high level design really right. It's brilliant, but he clearly was not thinking in an adversarial context at this time, and he doesn't start thinking about it that way until start of 2010, and he doesn't look at the script system after he's thinking that way until June 17th, probably, of 2010. And then there's clearly this panic mode, and he ships 4 big updates and continues to sneak stuff in all the way through to November of 2010. And then he disappears about a month later. And that's when WikiLeaks was in the news, and it was Bitcoin's first big primetime thing, kind of in the American, Anglosphere news cycle. And it's possible that Satoshi was worried that he hadn't made himself quite anonymous enough. And of course, various governments made examples of all the people who did similar things to Satoshi up until this time. So basically, he kind of dropped the final version. I guess it was December 13th, 2010, and then disappeared. And hopefully continued working on it as another name, but certainly no more changes to the script system. But yeah, there were a number of other issues that continued being fixed, and there was another standardness was developed at the end of 2010, early 2011. That was kind of one of Gavin's first big contributions, and that I would say resolved the remainder of all of the critical issues. But it's helpful to have that context. I know that was kind of long-winded. Helpful to have that context when you note that the script system doesn't have loops, and the fact that it doesn't have loops almost became part of the mythos of it. It's the first thing anybody who's interested in Bitcoin script, the first thing they read on the Wikipedia page or whatever is that it's Forth-like, non-Turing complete, whatever. It has no loops. And people say that because it's the easiest thing to say about the code. Because there's literally a comment at the top that Satoshi never removed that said, script is a predicate system. It has no loops. And after the first big change, July 29th or whatever, his entire approach to limiting the script system changed. But he, of course, didn't pull out that comment. And so that comment continued to guide people's perception of the script system for the next 5 years or whatever, even though clearly Satoshi changed his mind about the whole no loops being a meaningful way to limit the script system. So he added all these other limits. And of course, he's in firefighting mode. But that's why I would say the fence is there from about 4 versions ago. And I think if Satoshi had continued working on it and was very certain, once he had gotten big numbers on again, once he had found a big number implementation, he was convinced it wasn't going to cause a network split. And this is also around the time of the overflow bug. It was all together. In fact, he probably rushed to ship the opcode disabling commit because of the overflow bug. He actually committed it 30 minutes before the overflow bug fix. So yeah, you can tell that like he fixes it in a change called miscellaneous changes. 30 minutes
Terrible
later,
developer practice.
Tiny patch that fixes the overflow thing. And so, I'm sure there were, a dozen people now already looking at the code who were capable of realizing that, oh, Satoshi just fixed a bunch of issues, but we're only going to talk about the overflow stuff because, those issues,
better not to bring to light.
Fixed now, and actually, you could even consider the possibility that Satoshi triggered the overflow bug as part of, on accident, as part of his testing for the miscellaneous changes, right? It wouldn't be too far out of the realm of possibility. I think it's unlikely because he has to work really hard to get things back online. It's clear that he's sweating bullets for this day or two when he's fixing the overflow bug, but and kind of the network operational triage, where he's explaining to people how to reset how to roll back a little bit and resync, not all the way from the start because they don't want the whole network to go down with all the bandwidth it would require and stuff.
The overflow, is that
he triggered it, but it is like close enough to when he's working on that kind of thing. He's like, this is when he's pulling out BigInt, he's pulling out OpenSSL's, he's pulling out the dependency on OpenSSL. So he's like experimenting at the edges of all of these protocol sharp edges. And it's plausible that either he or Gavin or somebody who he's talking with over email about all these changes, somebody accidentally did it essentially. And that might've been why we found out about it so quickly, who knows?
So that's when somebody printed billions of Bitcoin. I've just quickly Googled 92 people got 92.2 billion Bitcoins each, which ruins the whole 21 million and obviously had to be hastily patched up, right? This is a very famous incident.
Yeah, and I think it was an overflow, if I recall it correctly, it was in OpenSSL's big number implementation. I mean, it was just another thing where big number was just a mess, and like 6 hours or something after it's first reported on Bitcoin Talk, Satoshi fixes all, rips out OpenSSL, cuts the numbers down to 4 bytes, disables all these opcodes. I'm sure he was working on this patch up until now, but this was his opportunity to get it out there before essentially a forced upgrade, because everybody was going to have to upgrade after the overflow bug. So yeah, I think hopefully that gives you a perspective of how we got where we are, and why there's this kind of blind assumption that the script system needs to have no loops, and that like being Turing incomplete matters at all. It doesn't matter, not even a little bit. The script system has not used that as a limit since July 29th of 2010. And then of course there were other limits in the July 31st and August 15th, and there's a September 6th and then November 7th or whatever. All sorts of changes. He limits his first scheduled soft forks are around this period when he realizes his previous idea of how the upgrades will happen. That gets all thrown out. That's not happening at all. He had to disable op version, obviously. So he rolls out the block size limit. He rolls out as a scheduled upgrade, as a scheduled soft fork, and then there on out he schedules everything. He schedules the limit on check multisig. Before it was possible to have a check multisig like one of 10,000 or whatever, and it would try to check the signature against 10,000 different public keys or whatever. It was a very efficient way to waste a ton of time, and he limits it to 20 public keys, but schedules that for a scheduled hard fork. And then he has a scheduled cleanup. After the hard fork happens, he sneaks in another commit to clean it up. So I think he's likely he was talking to somebody at the time, if I recall correctly. Gavin has said on talks before that he was emailing, and maybe Mike Hearn too, were emailing back and forth with Satoshi at this time. And it's like a month later that Gavin starts his work on the is standard system, because even after they disabled all those opcodes, they're still like, oh man, this system could be just riddled with things that will destroy Bitcoin. And we are early enough that like they just, air quotes, they just kicked the hornet's nest because WikiLeaks was a big political topic, and some people were promoting having WikiLeaks accept Bitcoin, even though, the volume in Bitcoin was just completely trivial compared to even the size of WikiLeaks at the time. And that is likely why Satoshi decided to go ahead and call his pseudonym off and stop using it.
So that was the problem, right? That was how we got into this whole mess. And then basically nothing has changed essentially on this front until today. And you're proposing a fix with this VM limit chip. So tell me about that.
Yeah. So it retargets the limits to be to basically to equalize the costs between, malicious uses and honest use cases of the contract system. So the absolute worst case time it takes to validate a transaction should not change at all. But there's no reason for us to have a 200 operation limit. That's right now, it's a 201 opcode limit for every contract. And kind of to put it in perspective, you can make some contracts within that 201 limit that are more than 10,000 times more expensive to validate than the least expensive to validate. And honestly, it's not even really measurable, because you can make you can actually make a 200 operation contract that's just swaps, and it's essentially instant to validate. And the hashing and signature checking can be hundreds of thousands of times more expensive. So there's this giant gap between what you can do if you want to waste everybody's time. If you want to waste processing power, you can waste a lot of processing power. But if you want to write a useful contract, you're still limited to that 200 operations thing, even if you're just like moving things around. So it doesn't take much to do better than that. And it's worth noting at the time also, it appears that Satoshi knew that there were better ways to do this stuff, because he's like very carefully choosing constants. That now over the past four months or so, I've had the opportunity to do some benchmarking, and I can tell that actually the max number size he chose with the code at the time was very, very close to the maximum. The validation time for the worst case there was very close to the worst case hashing time. So it's clear that he's like benchmarking them together, and he's kind of picked them for the same levels. But it's also notable that I think the reason he likely picked the opcode limit to be so naive is in part because first he needed to sneak it in. And so the opcode limit was one line. But then probably more importantly, this was when he was figuring out how upgrades can actually happen. He's scheduling upgrades now. And he... Don't
worry too much about that. We got 2 hours. We got to get on a bit more. Let's hear about the solution.
Yeah. So opcodes are very easy. The opcode limit is very easy to upgrade safely without breaking user land, and that's probably what's most key about it. And a notable challenge with the limits chip, something we need to get really right, is if we move away from just counting opcodes, we need to essentially get it perfect the first time, because we can only safely raise limits without breaking user land. We can't reduce them. But
can't we do a small raise and then, kind of build up over time there, as long as we were conservative?
Exactly. And what I mean by that is if we get the limits chip wrong, and there's some way that is significantly worse than the current case, there's no way to really fix that once you ship it. You just have to live with things being much worse. So that's why it was so important to benchmark like crazy. And so I've gotten to work with Callan a little bit from BCH. He implemented the LibAuth's benchmarking suite, which for the virtual machine, which I've been working on for quite some time, and I've been working on benchmarks now, kind of just manually working on the worst case benchmarks for the past 4 months or so, and exploring the edges of worst case performance times. And there are a few places where the limits likely will settle now in the limits chip. essentially hashing is, of course, the worst thing. Signature checking is bad as well, but because it includes hashing. And then the signature checking also is expensive. But generally, the worst of signature checking happens when you have to hash a lot to do the signature check. And so those things need to be carefully accounted for. And then something that was maybe a little bit surprising to me was that arithmetic does need to be meaningfully limited. Even just 64-bit arithmetic is notably different enough from all of the other opcodes that it does need a limit. And that's where we'll get into the whole BigInts discussion, because it was only after doing quite a bit of benchmarking did I realize that the limits chip really is going to have it's going to have to account properly for arithmetic cost. Which means that the limits chip will have a BigInt size hole in it, whether or not BigInt happens this year. And so I was talking to Callan, and I've been talking about that for a little bit. And after he explored a little bit how difficult it would be to get that implemented in BCH in a way that we would be confident is really ready to go, really rock solid. We decided that it seems viable to try to push it for this year. So we need to talk to some of the other node teams and see how other people take it. But for example, the JavaScript implementation already uses BigInt, and a number of other programming languages already have native BigInt primitives. So it's really just the C++ implementation that this is much of a change for. For most implementations, this is a change of a single variable from 8 to 258. So the JavaScript implementation, for example, quite literally, when you do a math operation, it just counts how long it is. And if it's longer than 8, it fails it. And so I just have to change that constant and it's done. So it is in itself, it is a limit if your implementation was already using big integers under the hood. And now the C++ one has not been since August 15th of 2010. And so that is a meaningful thing to work on. But that has developed a lot in the past couple of weeks when we realized that limits would have to account for it. In part because if we shipped limits this year and then tried to ship BigInt next year, for example, and we found an issue in the limits when we're testing BigInt really well, we can't fix it if we don't ship it at the same time. And so that's why it's, I would say, pretty important for them to go together, either this year or the next year. So I think that it's very viable for us to complete really thorough testing for this year. We have a very solid set of benchmarks now, and we'll need to try it on a few of the other implementations, of course, but it is looking very good.
Okay, so just walk me through then that in a little bit more detail. I was asking Emergent Reasons, who I'm sure you know well, about this, right? He's a big, fan of the chip process and all that. And so he was really like, yeah, I mean, it's already July, and this, like you said, this has been a sort of thing that's now come out of the woodwork in the last couple of weeks as to, okay, well, the VM limits was already gaining traction. I could see people kind of like, okay, we've seen this coming ahead of time, but now this whole bigger integers bit coming in there. And like you say, okay, maybe it kind of needs to be both at the same time, either this year or next year. Just give me a bit more detail on what your thoughts are for, is it really a big deal if we delay it until next year? Would it be better to just cram it all in like now? How are you planning to have everyone convinced that that's not a big change that would be a problem, and there'd be enough scrutiny of it before November, obviously?
Yeah, for sure. Right. So in general, the BigInt chip is itself a limit. It is one of the limits. So it's a little bit different because you do need some capability behind it. But for a number of the implementations, they already use big integers under the hood. It is a meaningful probably the biggest challenge is for C++ implementations, because C++ does not include a built-in big integer. And so the first place I went to see how viable this was to check with the Bitcoin Cash node team. And that's what Callan is exploring right now. So I do think that it is possible for us to get it. It's going to be a lot of work. But I do think it's possible for us to get it rock solid in 4 more months before a lock-in, and then another 6 months after that. I mean, we are still almost 10 months out from a possible deployment. We'll have to see where it develops, because in talking with some of the other node teams already, in general, I think. I was a big problem in not having big integers already. I personally am one of the reasons why we don't have big integers already, because I am necessarily very cautious about what happens with the virtual machine system. And in my 2021 opinion, the most conservative thing to do was to deploy 64-bit math and then wait until we had a better sense for what higher precision math should look like in contracts. Because we know it's technically possible to emulate higher precision math, but that's part of what I've been doing the past 4 months or so. And then also when I was working on JetX in 2022, I guess the decentralized exchange concept using cash tokens. Essentially, what limited that from being deployed immediately is just that the market maker contract requires more work to do the emulated math properly and then to review it properly. So it's notable that something that actually genuinely holds back some meaningful development right now is that in order to do anything higher than 64-bit, you change your development cost from being something you can do in a day to being something that is like a multi-week or maybe more than a month project. And it can be resolved. That can be resolved with libraries for higher precision math. But those really do have a lot of foot guns, because you do need to review a library in the context of your contract if you want to make sure that it's actually secure. And there have been actual exploits on Ethereum contracts because the big number library they're using is vulnerable. So I think Satoshi's original choice here, having all numbers being big nums, is brilliant and most correct in the very long term for contracts to avoid some very serious vulnerabilities and reduce the cost to review and things like that. But in my experimenting with it in the past 4 months or so, I also was experimenting with different ways of emulating higher precision math. And basically, because our numbers were originally based on big integers, some of the tricks that you can use for emulating higher precision math are actually a little bit more expensive with our numbers than they would be if Satoshi had not chosen big numbers. And so quite honestly, it would be embarrassing if Bitcoin Cash did not have big integers, and instead we had emulated precision math as the standard practice. But it took quite a bit of experimenting with the different possible approaches to it before I thoroughly convinced myself that it was crazy to try to do emulated precision as a standard procedure. In part because you end up any limit approach that we take towards reducing the cost of validating a transaction, like anything we do in the limits chip, in most cases significantly overrepresented the cost of doing the math. Like massively overrepresented it, between 10 and 100 times as bad as it actually costs for the actual computer doing the processing. So there are just a number of different factors pointing towards that we would be losing a big opportunity by not using the number format that we have. Not the least of which the number format is quite literally more efficient to do math on because of how it's laid out in the virtual machine. because it is a big number format. The sign magnitude format is quite simply easier to manipulate for these very large calculations. So there are a number of reasons where it kind of all roads led to essentially in the past month or so, forcing me to reconsider my previously held very solid belief that we shouldn't touch that because we wanted to maximize future options until we knew what the contract ecosystem was going to do with it. I think actually when I started messaging people about, hey guys, I'm starting to think that we really do need BigInts maybe in 2026. It was all just sighs of relief. Just like, oh, thank God, you were the problem before. So we'll see, of course, how other implementations feel about implementing it. Many of them, it's just going to be a constant change, but we'll definitely want to really kick the tires on it. I think I'm almost at a place where I think it might be unwise to deploy limits without BigInt because of that. If we're not willing to kick the tires enough on BigInt to ship it in 2025, then we have not kicked the tires on limits enough to ship it in 2025. That's but that is my evolved opinion now in this week or so, because we really just don't want there to be any unknowns. We need to have and so the LibAuth benchmarking suite now has this, we've talked about this a little bit, but in LibAuth, I have many of the, cleverly designed worst case contracts where you do silly things like duplicate public keys so that you can check the signature against the same public key lots of times. There are ways of getting more cycles out of the malicious contracts than honest contracts are able to get. And we've put together quite the set of benchmarks of kind of all the things we already knew were worst cases. And the hope is now over the next month or two to also just get a combinatorial set of tests that essentially test every operation in every way that it gets used, so that we also have just a general performance profile of every operation, even if it's silly stuff like op-rot or whatever. If for some reason your random implementation is very inefficient in its rotation command, then the benchmarks would reveal it. And so the intention is to get to well beyond 100% coverage in our benchmarks, and then test it against all of the implementations. And that's when you find things like for example, in the JavaScript implementation, I had bugs in 2019 or something when it was copying by reference rather than by value. And so if you modified something on the stack, it might modify something a little bit deeper in some random way. So there's things like that if you're just testing one implementation, it's easy to not have tests for that. But testing all of these implementations and then having benchmarks for all of them and having all of them contribute tests and benchmarks, I think we'll end up with a really solid battery of performance tests and also like functional tests for how the virtual machine should work. But
okay. Until we have so hang on a second. So what I'm hearing, right, is that there's two ways. You say we've got to ship BigInts with the VM limits as it's a package deal, right? So then that means either 2025, probably, right, is 2025 or 2026. So give me the steelman case for both sides, right? If we do 2025, the upside is that we get a whole year of extra dev time on our contract ecosystem, obviously, instead of having to wait a year. But the downside is that if we don't test it all out properly, we cause an issue, like you said, where you only raise the limits once, you cause a problem, right? And then 2026 is the opposite. We give it more time to cook with the testing and we can be more solid on it, but we miss a year of dev time. Give me the both sides.
First, I'd say we are just about the perfect amount of time out from a possible November lock-in, that I think it's very useful to approach it as if we're pushing for 2025 for both. This is the right amount of time for all implementations to really, really test hard. Honestly, if we if we say we're going to do it in a year and 4 months, we're going to lock it in a year and 4 months, then we're going to be talking about this exactly 1 year from today, and everybody's going to start testing it exactly 1 year from today. And so, but I also wanted to go back to say that you said when you said it was a package deal, it definitely does not have to be a package deal. The testing has to be a package deal. If anybody has strong well thought out disagreements on why the virtual machine should not have big integers, now is the time for us to talk about that. We will have to do the testing as if it does, basically, because we won't be able to fix these limits later. So regardless of whether or not we give contract authors the ability to use integers, big integers, we will be testing them like crazy before November. And if we're not sure before November, then limits definitely shouldn't happen either. We should be sure before limits happens also. But I would say that it's not that they're not a package deal. They're definitely not a package deal. But the failure case for big integers is that we find convincing reasons why we should never have big integers. And if that's the case, we might also need to revise how limits would work because how Satoshi designed it is not going to be optimal.
Okay, so we do have to be pretty solid on the testing of the bigger integers,
right,
before we can ship in the limits. So yeah, tell me, so that was your argument, was we've got a few months. That's what people are going to spend the time on to look into it. And if we don't, devs are devs, they'll fill up the pipeline with something else and then they'll get around to it then when it's crunch time. That's a very realistic scenario. I agree with you about that. Although, have you talked to those teams about that, whether they want to make this their top priority for the next few months? Were they already angling in that direction? Are they going to say, Jason, I know, but I really wanted to make what's it, in the next 2 months?
I would say it goes back to that honestly, I was the problem before. By and large, there are a lot of projects that would be unblocked by built-in big integers. And so the reception is quite the other direction. They're like, yeah, if you guys could go ahead and get that shipped, we would like to deploy our project in May. And it would be, I think, at this point, disappointing to some of those people if that didn't happen. So the projects, the node implementations that will have the most to review are going to be the C++ ones. So Bitcoin Cash node, which is working on it, and then others that are derived from the C++. And I'm still waiting to hear back from a couple node implementations. I don't want to give any any indication.
Don't drop anyone in it.
I think that I'm cautiously optimistic that really the hardest one to do this in is BCHN, and BCHN is likely to have the first patch, the first of the live implementations. So yeah, I think now is the perfect amount of time to do some solid review. And obviously we're regardless of what happens, we're not going to treat it as even likely to happen until we're sure it's really solid in October or whatever. There are going to be some test nets, and every single implementation is going to probably upgrade before there's going to be general consensus that this is safe to happen by November. So we'll know in October if there's been enough time. But this is I would say a good amount of the schedule. I'll also say that process wise, it would be nice if I had finished this benchmarking and realized some of these issues early. Like I was working on limits in February. It would have been nice if I had stumbled on this stuff in February, right? And then I could publish this. And so on net, as far as chips go, I did kind of debate whether or not it should be a separate chip. I think it comes across with a better perception of like not being something that I'm trying to shove down everybody's throats. If it is a proper separate chip, but quite frankly, in Satoshi's implementation, it was one of the limits. And it actually only doesn't look like that in BCHN. It looks like that in most of the other implementations because it's one of those other arbitrary constants that's set along with 201 and 520 and 10,000. And there are all these constants that Satoshi carefully chose between July and August of 2010. And this was one of them. It was n max num size. And it was 258 until he set it down to 4. And we set it to 8 in 2022. But in the C++ implementation, that requires that we have a proper arbitrary precision implementation of multiplication, division, mod, add, and subtract. So it's definitely not trivial in Bitcoin Cash node, and we'll need to hear back from other implementations. Quite a few of the implementations, though, this does look like this is set as a limit. So it's a little bit weird in that typically a chip would be a little bit more clearly defined technical specification because it's about consensus code. In this case, the only consensus change is the constant. But in practice, node implementations either have big integer support or they don't, so they need to add it if it were to happen. But yeah, I'm again cautiously optimistic. But now is just the right amount of time to review it really, really well. And I won't be certain until October. I won't myself be certain until October. Yes. And certainly to get everybody else's feedback on it. But now is the time for us to have the conversation. If anyone has a credible reason why Satoshi's virtual machine works better without big numbers, now is the time for us to talk about that because we need to know that before limits happens. Yes. Okay. All right. So then walk me through a little bit. Yeah, maybe it is going to be kind of, all what's it called? Pedal to the metal, basically, on this to try and get it working. I'm just trying to, anticipate any concerns from anyone about that. Mm-hmm. Can you explain a little bit more about what the testing process is going to look like then? I mean, you said you've already worked on some of the testing suite stuff. You're presumably publishing that now and coming up soon as well too. What does that actually involve? Yeah. Awesome. Yeah, I first published the benchmark suite in LibAuth in like April or May, and BCHN also implemented the same suite. So there are essentially LibAuth, the LibAuth project produces 40,000 test vectors or so that are all proper transactions with the UTXO to simulate spending the transaction, or the set of UTXOs to simulate spending the transaction. And the idea is that your implementation should feed in the UTXO and the transaction and test how long it takes to validate and do it a bunch of times and get a proper benchmark out of it. And the rest of the tests, there are also a large set of functional tests, but these benchmarks are specifically designed to test every little aspect of the performance qualities of your implementation. Some of the first ones were done in May, but it then took me a couple more months of kind of banging on it to realize that we needed some around arithmetic. And then when I went to limit the arithmetic properly, it became clear that there was kind of no getting around that now is the time to decide whether or not Bitcoin Cash will have big integers. So the process now for other implementations that have and I've started to reach out, but I need to now that we have some of our current work published, some of the research, it is ready now for other implementations to just implement the same benchmarking strategy. So you can feed it a transaction in the JSON format that LibAuth pops out. So you can just copy over the files and run your benchmarks and get a reading of the couple hundred different performance tests. And the way it works actually is that there is one benchmark that we call the baseline benchmark. It is what we consider to be the most standard kind of transaction. It's a 2 input, 2 output P2PKH transaction. One is an ECDSA signature and one's a Schnorr signature. And that is like the most average transaction you could possibly have. It's actually a size that is almost the network average size also. So it's a very good estimate of what the average cost of validating a transaction should be. And then we run all of the other benchmarks and compare their actual runtime with that baseline. And the difference is what we're interested in from all these different implementations. So the baseline is a 1, and the worst case hashing is somewhere between 5 and 6. For non-standard, it's between 15 and 23 times. And it's actually quite consistent between, this gave me a lot of, one thing that gave me a lot of confidence actually is that it's very consistent between LibAuth and BCHN, the C++ implementation. So LibAuth being my rather weird JavaScript implementation with all sorts of debugging, tooling, and weird extra overhead in how operations get called. And it's actually the virtual machine implementation that powers the BitAuth ID live debugging editor. So just the fact that it has a very similar performance profile to how BCHN works, even despite all those various differences, built a lot of confidence that most implementations will have very similar performance characteristics. So we'll need to know what it looks like for Bitcoin Verda and Flowy and some of these others, hopefully BCHD. But it would be. We're very close. Basically, any implementation that wants to try them now, of course, could have since May, but now we have a whole bunch more benchmarks, so you can see exactly how a lot of other operations perform in your implementation. You just need to implement the benchmarking suite and feed it the test data we've generated. But next step is to get all the implementations to, if they don't have benchmarks already, to add them, and then to build out that benchmarking suite. So I would say the benchmarks probably cover well beyond 95% of what could possibly be an issue. But to get that last 5%, we just need a combinatorial test of literally every operation, everything that every operation could possibly do at its worst case. And once we have that set of benchmarks, I think we'll be very confident that once it's run through every implementation and nobody has found anything unexpected, we'll know all of the nooks and crannies that could possibly be a performance question. So I think 4 months is a good amount of time for implementations who don't have benchmarks yet to add them and pull that in and try it and compare them against the results from the JavaScript and the C++ now.
Okay, so we run this over the next 4 months. You get that extra set of combinatorial stuff done. We find a problem. Okay, maybe the whole thing waits a year. We don't find a problem. Everybody's on board with this. All the checks have been done, and then maybe they both ship for 2025 or lock in and then ship in May. Now, you mentioned to me that the ZCEs also get improved as a result of this. You were kind of a bit excited about that. And then you also brought up the looping before. When I asked around what questions people might have, there was also some interest in what you think should be next in terms of our protocol development after this VM limits and BigInts stuff, because I guess people are thinking ahead. And I'm also thinking about UTXO commitments as well too. Callan was talking about that at Bliss, but that's probably not on the cards for this year then, if the focus is going to be on the BigInts, right? Yeah.
Well, things can certainly happen at the same time, but I don't think there are any other proposals right now that are far enough along at this point to happen in 2025. There's some things we need to figure out still for a few of them, but I'll start with implications for limits. If BigInts were to happen in 2025, that would certainly be the biggest, most visible impact of the limits chip by far, and it's not close. There are a number of at least 3 development teams that I know of that are working on very big projects who would essentially shorten their development schedules by a couple months if they had the ability to use just higher precision arithmetic, even just 128 bits or 256 bits. But we do technically need more for some applications as well. But that alone would be a big deal for a number of applications to ship essentially tomorrow. Not the least of which the JetX, my first I spent a couple weeks putting together what I thought was a very Bitcoin Cash flavored decentralized exchange, something similar to what Uniswap is in the Ethereum ecosystem and some of these others. Something that is a global liquidity pool, has a liquidity provider, allows hundreds of people to be submitting orders simultaneously without interfering with each other's orders. Essentially, the only thing stopping that from being deployed tomorrow is implementing and verifying the math part. And it's quite silly, actually, that would be the only issue. But there's limited developer bandwidth, and I have not spent the time on it. Nobody else has either. There's been some work on Mathieu G has actually implemented some emulated precision math stuff. But it was quite funny when Callan brought up in a chat group the other day, and everybody who had worked on emulated precision already within a few minutes was like, oh man, I can't wait to throw that away. So, I mean, the general perspective there is that emulated precision, for anybody who has messed with it, is a monster that we should not curse future Bitcoin Cash developers with.
Yes.
Yeah. So by far the biggest impact of these 2 upgrades, if both of them were to happen, would be that unblocking of intermediate higher precision math in order to do things like decentralized exchanges and balancing swaps and stuff. But also the zero confirmation escrow stuff. The treeless zero confirmation escrows, an evolution of the original proposal from 2021. One of its most significant downsides is that it only could support up to 3 inputs in the transactions, in ZCE transactions, which ends up being not always an issue, but enough of an issue sometimes to be a meaningful limiter for getting it developed. So it's nice that limits simply increasing the largest possible push would alone unblock implementation in wallets there. There are some other there is other work to be done in that vein. The double spend proofs have some work to be done, both before the CashTokens upgrade and now with the CashTokens upgrade. There are a couple SIG hash types that need to be covered properly. But we knew that at the time, and that's one of the reasons that ZCEs is just a lot of work to get done. Is being able to have a network broadcast the offending transaction material in order to execute the ZCEs and have the miners confiscate the escrow. But I am very excited about that in the medium term. 2025 and 2026. I think that we will be able to have zero conf payments that are have the same incentive security as a 1 conf payment. And in practice, they'll have the same incentive security as a 10 conf payment because they will themselves have a greater bounty on the reversal for the miner than the overall value of the contract. And the trade-off there being is the user needs to have instantaneously, they need twice as much money as they're spending, but they get to spend that money immediately. So it really just means they need to have some extra BCH in their wallet. And if you have enough extra BCH in your wallet, you can send fast payments. and they are incentive secure permanently without any changes to the mining algorithm or block times or anything like that, without any post consensus or anything like that. It is definitely a bit of a holy grail, because you can actually receive the payment as a merchant. You can receive the payment and you can validate it instantaneously. You actually don't have to listen to the network, because hypothetically you would have heard the conflict come in the 5 seconds before that transaction.
Yes.
And if you didn't hear the conflict in the 5 seconds before, then you know that incentive wise, you're going to win regardless of what happens now. that the miners would actually be leaving money on the table. That a colluding malicious miner is more likely to backstab the fraudster than they are to backstab you with the fraudster. So I'm very excited in general about that approach to handling zero conf, and it's important not just for typical, in-person payments or whatever. It's also important for decentralized applications where you can have a decentralized exchange that has zero conf finality. It is possible to have zero conf finality in much more complicated contracts. So there's definitely a lot to be explored there, but not imminently. That's more medium term. In the short term, by far the biggest impact is that there are 2 or 3 projects that are right now tearing their hair out about emulated precision, and there's a window where they might not have to deal with it come May. So we'll see how review looks in the next few months, and we'll have more certainty then. But
yes, no, I like that ZCE thing, because people have been talking about block times. It's just been a bit on the community's mind, but I'm sort of more on the side of like, look, if we just had better zero conf, and especially rollout, which is partly a matter of us just pushing adoption and getting to a critical mass with, merchant providers and such like that, that would actually just fix the problem, and that could also be a huge help. So tell me, let's get on then, loops and UTXO commitments, bring those into the story for potentially on the upcoming sort of dev roadmap. Thoughts on each of those?
Well, I can start. UTXO commitments I've barely touched at all since like 2014 or something like that. Definitely not in Bitcoin Cash years. And so I'm not a good spot to speak to that at all. It's something I have to think about a little bit with the limits. We need to make sure that the limits do not preclude some possible future upgrades that will be important for UTXO set stuff. One of them being, if in the future we did want to relax standardness and allow outputs to have a contract of any type instead of forcing them to be in pay to script hash, that would be valuable for contract authors, because it would save 32 bytes per transaction per input. But it's definitely not trivial to implement on the node side. We need to make sure that we don't break that possibility with how we implement the limits. So it's something I've had to think about there in that context. But I'm not a good one to speak to the larger question of the UTXO commitments. There's a couple other guys working on that, as far as I know. But for loops, I'll say that the past 4 months or so, I've also been reviewing very hard what it looks like to deploy loops possibly in 2026, and so I will propose the loops chip. I will repropose for 2026 now, and I consider that quite a bit different than the limits and the big integers, because that is. It's a little bit like adding syntax to our language. Like if the way that works, we want to make sure is really, really right. And to do that, we need people to play with it for a little while. So actually, a few hours ago, I shipped the version that I've been messing with in my benchmarking and testing. I shipped it for BitAuth IDE, so people can play with loops live in real time with BigInts and etc. You can mess with it in your contracts, and there's a useful visualization UI now where you can click on the place where it shows you how many times this loop iterated, and you can use a scrubber to see exactly what the stack looked like across the evaluation for each iteration of the evaluation. But anyhow, I'm definitely cautiously excited about loops possibly for 2026. I think there'll be of course, similar to limits, that it's technically possible to do anything you can do already. Anything you'll be able to do with loops, it's technically possible to do right now. But you can think of the bounded loops proposal as actually just being a very advanced compression tactic. The loops are very, very strictly bounded to the same length as the script contract. So it's actually, if you use a contract with a loop in it, it's actually more limited than if you copied and pasted the code that's inside of the loop. The interpreter can actually bail out earlier if you used a loop than if you copied and pasted it. So it's performance-wise on that side, loops are actually better. I'm quite a bit more confident now, having reviewed Satoshi's approach to the system, that the reason it didn't begin with loops is quite simply because his approach to limits was kind of poorly thought out at the earliest days, and clearly by his first big iteration, he had abandoned that tactic entirely. And essentially, the only reason loops have been kind of out of bounds for discussion in Bitcoin development land since then is because he left in a comment saying that script has no loops. And it's almost a joke that everybody just kind of read that and they're like, okay, no further discussion. So there's nothing fundamentally stopping you from having an opcode. It's a very simple implementation where you just, instead of copying and pasting all those opcodes, you have it go back and run them again. And if it gets to 10,000 operations when it normally would bail, it will bail. And actually it can bail earlier because it can calculate like, hey, if I jump back now,
still take it over
I will run out of space by the end of the program. So I can just quit now. I don't have to jump back. So it is actually technically faster than if you just copied and pasted the operations. You could copy and paste the operations and the interpreter wouldn't know until the last of the 10,000 operations that this contract was going to fail. But if you do it with loops, it knows 500 operations earlier or whatever. So from a purely technical perspective, there's no reason at all not to do loops. Importantly, along with it being a way to compress, duplicated operations, something where a contract that should cost, I have an example actually in the loops chip where a contract that should be like 8 bytes is like 70, because, you have to not only do you have to essentially copy and paste the operations that would be executed in the loop, you might have a place where you're picking from the stack and checking a variable and then doing something different based on its value. And if you have to have the logic to do something different copied 4 more times, you actually get this, the worst case is worse than a factorial increase in the length of the program. So as far as ways to reduce transaction sizes, there really are no better ways to reduce transaction sizes right now than to have some sort of looping construct. So the general plan there for hopefully promoting the loops chip for 2026 is it's now available in all of my software, and so BitAuth IDE people can experiment with it. And now is the time for us to figure out if it's the right syntax. Things are made quite a bit easier in that the script system is based on a pre-existing programming language. We're dealing with a language that's now 50 years old. We know pretty well what it looks like to use op begin, op until type loops, and they are essentially unchanged from how most dialects of Forth used them in the proposal that I proposed in 2021, and then I updated it a few months later in 2021 to change how it worked just slightly to save a byte and save 1 byte in a lot of cases. But it hasn't changed since then, and I don't think it will actually. After experimenting with it more in the past 4 months, I have yet to find any other little edge cases or anything where we would optimize it anymore, or where there would be an alternative structure that would be more useful or better in some way, more compressed in some way. So I'm pretty excited about where that is, and I think I will push that for 2026. I'll be excited to see what contract devs how they experiment with it. I imagine most contracts will be made quite a bit. Many contracts will be made quite a bit shorter. There are a lot of contracts that don't require loops at all, but there are some kinds of contracts where right now the only way you can make, for example, 3 or 4 different contracts work together in the same transaction is if every contract for that transaction was incredibly careful about which inputs it checks and which outputs it checks. And they all are designed to work together just seamlessly. And they are essentially hard-coded to know how many inputs there will be. It is not practically possible to have multiple smart contracts work together in many cases, where the number of inputs is variable. And with loops, that becomes trivial. So that is kind of a contract developer nice. It's a nice to have thing that is so much nicer than the current scenario that there's a good chance that there are some really notable use cases that are meaningfully prevented by not having it. But again, you can think of it as being a way to compress the contract, because if you had unlimited contract size, you would just copy and paste as much as you need. You'd have every possible code path would just be copied and pasted out into the location that it needs to be. But as soon as you get to like 2 different if statements inside of a loop, you're dealing with something that's much more than a factorial increase in the length of the contract.
Yeah. Okay. We're running out of time, so I got to try and cram in a couple more topics that I want to get your thoughts on. Okay, first up, cash tokens. You obviously were the grandfather of that in some sense, shepherding the chip through and all that. We've had 15 months of it live. How do you think things are doing? I mean, obviously talking about JetX a little bit before, but otherwise, how are you feeling?
Going great. I would say, in general, we started from not having tokens on this chain at all. And, maybe more importantly, a completely different architectural model to essentially any other network out there. So I'm delighted with where we are right now because architecturally we're in a very good spot. Like technically, no one else has a token system that holds a candle to it. But we have a lot of development essentially real world development where, average businesses need to issue their loyalty points or issue stored credit as a cash token to make on-chain cash token decentralized applications be super useful. Right now, of course, it's a useful way of keeping track of like conference tickets. It's the perfect use case already. And I hope that we see in the next couple of years. And I'm very excited about a couple different efforts to do, for example, stable coins and loyalty point systems. There are a lot of good things happening, and those things simply take time in the real world, not development time for developers here. It's about actual businesses shipping the physical things that are required to make these systems useful. But yeah, I think that over the next few years, I'm very excited to see more real world assets and real world value be tied to cash tokens as a way of having the Bitcoin economy, the Bitcoin cash economy have its own ties of value on chain. And certainly the dream is to get the majority of Bitcoin cash trading, literally Bitcoin cash trading, happening on the Bitcoin Cash chain. That would immediately break the bucket shops, of course.
Yes.
If pricing power was something that was forced to happen on the Bitcoin Cash chain, where you can't even pretend to have fractional reserves. You have to have full reserves because everybody can see it in the contract, right? That would it would definitely be a game changer, even for the larger crypto space, because many of the economies, many of the cryptocurrencies that currently have tokens have serious architectural or social issues that cause them to not be capable of hosting their own trading. And so they are all custodial, or they're all, in the worst cases, there are systems of custodial where there are market makers with special deals with those custodians so that the market makers don't actually have to deposit any collateral to sell that asset. And so there are market makers who get to sell Bitcoin Cash without depositing any Bitcoin Cash. They just have some Bitcoin on the exchange, right? And so they get credited for the value of the Bitcoin Cash, even though the only thing they have as collateral is Bitcoin. And that has definitely happened several times. We know it's happened several times with some of the exchanges that have collapsed, and we can see their books. And of course, it looks like it's happened a couple more times in the past couple of years. Something around June each year seems like something pops. But we'll see if whoever's having liquidity issues eventually goes belly up. But a good way to accelerate those things is if those builders in the Bitcoin Cash space, if you ship things in the real world that are worth real value, and you tie them to cash tokens via your business or whatever, if you simply issue your customers credit or gift cards or loyalty points or tickets or whatever, you issue them as cash tokens, that helps to get more real world value represented on chain such that it can be traded against. And when we have enough real world value on chain, we'll have decentralized exchanges that control pricing. And that's when you break the bucket shops, right?
Yes, brilliant. Okay, last question before we kind of go into the rundown to the outro. So I asked Mathieu, who you mentioned before as well, for some questions. He had 3, but I think we're only going to have time for 1, and I'm going to go for my most important one that I think I want to hear the answer to, which is, can people develop zero knowledge proof verifiers in script with the new VM limits? Recently, just this week, we saw on the BTC side, what's his name? Some guy came up with an opcat kind of thing that he was excited about doing a ZKP on BTC. How does things look on the BCH side? And
more recently, there was also another group that did a series of 52 transactions. They paid like $500 in transaction fees to execute 52 transactions where they essentially pre-computed lots of different ways of executing them and handed them to a trusted validator set. It's kind of
that was a BitVM thing, right? It sounds
I think it's a different thing. It's called Bitcoin OS. So there are 3 or 4 of them now. But notably, you can actually copy that contract into BitAuth IDE. I just posted in the Telegram group a minute ago. I just curiosity yesterday, copied it over, and a fun downstream effect of BTC essentially not having any script development since 2013 is that you can copy the contracts right into BitAuth IDE and execute it with the Bitcoin Cash VM. So I was able to review it. It actually passes in the Bitcoin Cash VM with the limit. So I can say definitively that the zero knowledge proof thing that happened a few days ago is compatible with Bitcoin Cash. That way, but more high level. BigInt certainly makes a lot of that possible. And I did not understand that very well in 2021. I did not have a good sense for how those things work together. And as did many of the people, if you look at the discussions from the last time we bumped script number size, widely considered 64-bit was a safe option regardless of what happened in the very long term. Whereas if you go any higher than that, you start to have technical debt depending on what the way that the big integers ultimately were used by contracts. I'm very excited that I think the big integer stuff by 2025, if we do get it deployed, certainly there are a lot of zero knowledge proof systems that are easy to implement with the number sizes that we would have, and certainly well within the limits also. I need to do a little bit more testing on specific zero knowledge proof systems, but I mean, at the very, very least, we can run 52 transactions in a row and have it work that way. But I think we can do a little bit more efficiently than that. And certainly it won't cost $500 in transaction fees. But I am excited about where that could be in a year or two for sure.
Okay, cool. We're doing good on time, so I'll sneak in another one. Is it still necessary to make a sidechain for prediction market applications once larger script limits allow for it on-chain?
I wrote at length about this actually in like 2019 or something like that. It's not technically, never been technically necessary. If I put on the economist hat, I would predict that it will be the solution that outcompetes an on-chain solution. But an on-chain solution can ship a lot faster and is a little bit more censorship resistant in that you don't have to maintain a separate network. You get to just piggyback off of Bitcoin Cash's existing broadcast mechanism. So I think we're likely to see a lot of like hybrid strategy. I think we're even likely to see a prediction, one or more prediction markets, or even decentralized court systems essentially deployed on chain that then move to a side chain. There's nothing that keeps a particular project on any one chain, and we've already seen this on other chains where they deploy on Ethereum or whatever and then launch their own chain, right? And in many cases, they keep their token on Ethereum, but in some cases, they just ship off all the way. don't even need to keep using whatever base layer they shipped on. In our case, I think that the prediction markets that are likely to outcompete are the ones that let you use Bitcoin Cash as a reserve asset. And so they will be pegged to Bitcoin Cash. And they'll have, of course, their own asset that represents shareholder value. But I do think that in the long term, you can optimize things a lot more if you deploy it as its own application. And Satoshi had similar thoughts on this, where merged mining was a clever way of sharing the consensus algorithm, but where the networks had their own fate, I think is how he described it. And in this case, there are specific algorithms that are going to be a lot more efficient to implement as part of the protocol rather than in the contract system. However, are they going to be that much more efficient than just implementing as contracts? Probably not enough to make a difference, a 10x difference, which is what it takes for companies to beat each other usually. And so some of the first ones to launch on-chain only, I do think eventually will evolve to have their own side chains because it is the optimal construction. But I wouldn't say that they're mutually exclusive, and I expect to see lots of hybrid models. And it's notable that even if you do a prediction market on chain, and maybe I could post a link to what I said before, the automata versus side chains question. It's notable that especially for a prediction market, you trust ultimately, the bottleneck in trust is the group of people that say what actually happened, or the group of entities that say what actually happened, whatever protocol they use to do that determination. And fundamentally, if you have that group of people operating in some way on a contract on the Bitcoin Cash chain, there is nothing preventing you from having a separate network where that same group of people comes to the same consensus and then reveals to the Bitcoin Cash network the consensus they came to. So the trust model is actually equivalent, regardless of whether or not you do it on chain or as a side chain. You're still trusting the validator set, if you will. So yeah, it's a hard question. I expect we'll see both and mixes of both.
Yeah, we've got a lot of catching up. I mean, you were talking before about JetX and Uniswap and all that. I'm thinking, okay, it's going to take us another year, maybe to catch. Like BCH is in a strange spot because just the protocol is like streaking ahead of the rest of the industry. But just because we're limited on resources and on talent and a lot of different things, time, we're still catching up a lot on those applications. And prediction markets are really getting rolling on other coins right now, or they're already, kicking the hell off. So we're going to have to catch up to that, but we've got a couple other things we've got to do in the meantime. So yeah,
I'm definitely excited about how that industry is developing. And I do think that we've got a good shot of being, not the first, as Peter Thiel puts it, not the first mover. You want to be the last mover.
But the best. Exactly.
The final mover is the one that got so big that nobody else tried to compete essentially. And
yes,
I think that, technically, from a technical perspective, we're in a far better position than any of the other base layers on which prediction markets are being deployed. And it's not close. But where we definitely lack development is actually in the real world deployment of real world value as cash tokens. And it's not a trivial problem, because cash tokens are a little bit different than other token systems in that they, in a sense, both from a performance perspective, and then also from a guarantees to the user's perspective. Because, for example, if you deploy a token on Ethereum, it is, in many cases, and most of the tokens, it's effectively like using Ethereum as a spreadsheet, because all of these tokens have admin keys where they can just take your balance and give it to somebody else. They can mint new tokens whenever they want. They can change the rules right, middle of nowhere whenever they want. And there are even ones that, are supposedly immutable, but then they deploy a new immutable contract and have a migration strategy because they need a new one. And in the new one, they have a confiscation strategy. So I mean, it's just, there's no getting around that. And it doesn't even begin to describe that you need to review carefully every contract to see what its guarantees are around the token system. And so Bitcoin Cash, I would say, is a little bit of a sea change difference in that at least cash tokens at least always reliably behave the way you expect them to behave. But having a cash token in your wallet will fully guarantee that it works the same way as every other cash token in your wallet. And it is possible to implement, confiscation strategies or chargeback strategies and things like that. But you need to get affirmative consent from the user. It is fully informed consent, because they need to install a wallet or import a wallet template into their wallet that supports using that chargeback system or that fallback security system or whatever it is.
Yeah. Okay. All right. Last thing, message to the community. Your chance, open platform. What does the BCH community need to hear? You can make it a big pitch for VM limits, or you can say anything else you feel people need to hear.
Yeah, I'd say build stuff with cash tokens where you do things in the real world based on those cash tokens. That is the most important thing, in my opinion, that you can do right now in the Bitcoin Cash world. Both for adoption, because there are lots of useful things that you get out of a system of wide compatibility between lots of different wallets, right? There are 4 different wallets or so that can move your assets around now if you use cash tokens. Users get to choose how they want to hold your gift cards or whatever. So if you are a smaller merchant, or if you're newer to a particular space and you don't already have a fiefdom around how you manage your credit, your gift cards, now's the time to outcompete your competitors by offering your users a better product. Your users want a product that isn't annoying, and it's annoying to have a separate app for every gift card, or God forbid have a Ziploc bag of all of their gift cards sitting in their car console or whatever. So there's a lot of ways you can improve on just the real physical world with just the tool of a little token that you can send between different wallets that are made by different companies that nobody controls, censorship resistant, et cetera. Have guarantees around how they behave in your wallet. Nobody's going to confiscate it, et cetera.
Brilliant. Okay, I love it. Supporter appreciation. Thank you to our donators. Thank you to our patrons, Ricky and HP. Thank you to our sponsor, General Protocols. Check out bchbull.com. And our Flipstarter did actually get funded, which was excellent. Thanks to Majamalu Marcelo. Check out 2024.bcharg.com for tickets to the BCH Argentina conference. Molecular, Erdogan Talk, Turek, Emergent Reasons, Big V and the Bitcoin Cash Tokyo Gang, Peter McCormack, Brian Kanachi, Mini Satoshi, and beer. Thank you, everybody, for watching. The Start Guide, FAQs, and links are at bitcoincashpodcast.com. If you're new, check out episode 85. If you want to hear more from Jason, I believe it was episode 79 he was on previously. You can go wrap your head around that. We've got Celine.cash for our wallet, which now has user stats. We'll be talking about that on the next episode. That's already hitting all-time highs like a boss regularly. And a final shout outs. Jet, do you have one? Nope. Jason, final shout outs, and where can people find more of you?
Well, shout out to Callan, who's helped get the benchmarking stuff implemented to BCHN and answered some questions, helped me to validate some of my things that I was pretty certain of, but wanted to get somebody who understood what they were looking at a lot better to make sure that my understanding was correct. So thank you very much, Callan, for that help over the past 4 months or so. And you can find stuff on Bitcoin Cash research from me. I have a website, bitjason.com, bitjson.com. That'll take you to my blog where I just post things that I'm working on. But that's it.
Funny story. When I was in university, my housemate was a New Zealand Kiwi guy, and his name was also Jason, and so I used to call him Jason, like JSON, to troll him, and he hated it. But then you love it, and you've actually adopted it as your moniker. So I've always thought that was funny. He was also a techie guy. He knew what it was and stuff like that, but he could not have a bar of it. So I always thought it was funny that you were just like, no, this is cool, because it is cool. My shout out goes to Callisti and Steve Thurmond, who will be on the show. We're doing a double header weekend. So Monday night at 1900 UTC, we're going to do another show and talk about everything that's at the BTC conference. They're out there now getting into the mix. So I will be hearing more from them on that, and regular listeners to the show can look forward to that. All right, cool. That'll do it, everyone. Thank you for listening. Till next time.
They can't fuck with my gang. Got cash in the left and the right hand. They run Ponzi, they run scams. They're not like us and we don't like Manda. We achieve more in a short time span. Less is more and it's all by plan. When I draw for the war chest, they have all plans. Of course, we a small team, but we all bang and we ride for the cause. Riding for mine like I'm riding for yours. Keeping it right just to ride for the applause. And they do it so lies and shy, so it's more time walking with a rifle and sword. Cause we freedom fighters, 007, but don't need no license. They ain't got honors and degrees, just websites. Don't sign up before you read that fine print. Who the fuck ever told these clowns it was over? I roll with the mind of a soldier. By my composure, poses, try to oppose wave sticks like I'm a composer. Slides with the composure, you won't get spun like a CDJ. Boy, better know like BBK. What I keep in this piece ain't BB pellets. Get low when you see me spray. BBL, you can see they're fake. See these L's when you see this face. Cause we upgraded and upstaging, so when they get the next updates, it'll be too late. They ain't got the tech that we got, the techers we got, our intellect to keep pace. We let them rest in peace, we're the best to speak of, no less. They don't really wanna play no games. Who we playing is BCH. Play. They don't really wanna say our name. Who we saying is BCH. Play. Do you wanna keep it real or fake? Who we saying is BCH. Play. Who we really wanna hear you say? Who we playing is BCH. Play. They don't really wanna play no games. Who we playing is BCH. Play. They don't really wanna say our name. Who we saying is BCH. Play. Do you wanna keep it real or fake? Who we saying is BCH. Play. Who we really wanna hear you say? Who we playing is BCH. Play. Don't be fooled by the glitz and glamour, lips and chatter, grifters, tricksters and Instagrammers. They're all phonies, just tricks and scammers. Shit when a Tony like it's Montana. No, it's Tony, cause you know we got a heart made of jealous turn green like they hit with gamma. I blitz like 4 when I lift this hammer. BCH when we lift this banner. Now let me explain this game. BCH play, but we ain't playing no games. You can make bets on it, then stake your claims. No middleman, only lock chains. I'm saying, and it's peer to peer. Been here for years, but the joker's smiling from ear to ear. And I text so advanced it'll pierce your gear. Let it ring to your head like you pierce your ear. And yeah, we the tried and tested. The rest they tried and